This is problem 7-119 from section 7.2.1. The CPM amusement park has decided to imitate the Screamer, but wants to make it even better. Their ride will consist of a circular track with a radius of 100 feet, and the center of the circle will be 50 feet underground. Passengers will board at the highest point, so they will begin with a blood-curdling drop. Write a function that relates to the angle traveled from the starting point to the height of the rider above or below the ground. So let's first determine which function is it going to be. Is it sine or cosine? Well, talking about the height of the rider above or below ground is going to make me think it's going to be sine. So let me write the general sine equation here that we talked about before break. Okay. So I have, this was for my amplitude, which makes up how high or like how stretched my sine curves are going to be with each other. This one is for left and right, and this one is for up and down, shifting the whole graph up, 2 spots or up 5 units or something, okay? So let's compare this, the typical equation is just y equals sine of x. Now we're going to talk about how is this different from the original Screamer, okay? So it's a radius of 100 feet. If we're talking about the typical sine graph, our graph only, remember when we graphed it like this thing was a 1 and this was a -1, and it went between there, right? Well, now it's going up to a radius of 100 feet, so that could be a distance of 100 away from the center, or it could be -100 from the center, or it could be something else, okay? But it's not 1 anymore. It's being multiplied by 100, okay? So instead of having a point at 0, 1, it would be like 0, 100. It's going to be a lot larger numbers. So first thing that we can change is y equals 100 times the sine of x something plus something. Okay? So that's what we know so far. Our amplitude is going to be 100. So we got that done. Done with 100. Next thing, it says the center of the circle will be 50 feet underground. If you think about the regular circle, it was right at the same level as the ground. But now I'm shifted down 50 feet. Okay? So I'm moving all of my numbers, which is this, I'm moving them down 50. Right? So everything's going to be lower 50. So this is going to be a minus 50 right on the outside. My K, my vertical shift is down 50 units. Okay? So we got that done. Let's see, last thing is they start at the highest point. On the old regular Screamer, they started over here at the side. They started at 0 degrees. Okay? Now they're starting up here at the top, which is 90 degrees, also called pi over 2. So instead of starting at 0, all my values are going to be larger by pi over 2. Instead of starting at 0, my first entry is going to be 0 plus pi over 2. So my first entry, my first input is really like it's 90 degrees or pi over 2. Okay, the starting value, if I plug this in to be a 0, because we normally start there, plus pi over 2 means I need to really find the sine of pi over 2. Find the height of that. Okay, so my final equation is going to be y equals 400 because I have larger numbers. They're not doing decimals or stuff smaller than 1 anymore. X plus pi over 2 because I'm now starting at pi over 2 instead of at 0 degrees. Pi over 2 is just 90 degrees. And I'm moving everything down 50 because I'm underground 50 now. Not starting at ground level, I'm moving it down 50 units under the ground. So here's our new equation to represent the new Screamer.